Correct. Then 2 ticker B 1 1 colon y is equal to what? I of 3. I of 3. Shall I write the default to this? What is default to this is? Other than this, what I can do, I can assign y is equal to what? If select line is xx or zz, I'm going to assign y to what? Let us take one ticker ex. This is a statement. Instead of writing dollar symbol, inputs to the select line is invalid input to the select line. I am writing, in this case, y should go what? One tick bx. This is also fine, right? If I am writing like this. Then what I need to do? End case. Then end case. End case. Then what I need to do? In the always, in the all. Now let us check for the syntax errors first. No error. Now you can write the test bench to this. What is test bench to this? Module TB reg 3 down to 0 of I reg 1 down to 0 of yes, then wire y, then we need to insert mux 4 cross 1 DUT of, shall I go port connection by default. Then initial begin, okay. So shall I generate the random value to this? I comma s is equal to percentage system task function dollar symbol run. Then okay, let me introduce the delay. Then dollar symbol display write the time, correct, comma. Okay, I is equal to percentage D, correct. Then S is equal to percentage B, comma, Y is equal to percentage B. The arguments are I, comma, S, comma, Y. Then let me finish, then end. So shall I repeat this part? Okay, repeat. Repeat up. Let us repeat for 5 times and begin. And before finish, I'm going to end the repeat. Then end the. It understood. Now let us check the result. So this is the output. So file input is 001. Select line is what? 00. So what it has to select? I0. 01 means I1. I1 will be selected. 01 is I1. I1 is 1. 1 will be selected. So 1 I3. I3 is selected here. Again 01 I0 will be selected. I1 will be selected. Now this is working as a what? Forecast on multiplexer using what statement it is? Case statement. Now can you do 1 cross 4 demultiplexer? 1 cross 4 demultiplexer using case statement. What is a demultiplexer is? Demultiplexer is opposite of what? Multiplexer. Can you write a program for demultiplexer using case statements? How to write? So the program is 1 cross 4 demux. 1 cross 4 demux using case statement. How to write? What is the demultiplexer? How many inputs will be there? One input. How many outputs will be there? 4 outputs. How many select lines will be there? Two select lines. So multiplexer is acting as a data distributor, data selector. Mux is acting as a data selector. Multiplexer is acting as a data distribution. Your input you are distributing to the outputs based upon your selection criteria. Correct. Then how to model this using case statement? How to model this using case statement? What is the logic for the case statement to model the 1x4 demux using case statement? Module, okay, let us write module. So demux, let us take 4x1. What are the inputs to this? I is a single input. S is a two inputs. Then Y is the four outputs. Then here input is what? I. And then another input is select line. This is what? 1 down to 0 of what? Yes. Output. Right. Right. 3 down to 0 of what? Y. Next, what I need to do? Behavioral model always at the rate of, let us start. Begin. Whenever I changes, input changes, select line changes, my always block will be responding to whenever it triggers. Always event triggers. Correct. So I am writing the star here. How to write a case statement to the demultiplexer? Case, correct. Case of what? Yes. Then what I need to do? What is the alternative? This is nothing but 2 tick B 00 colon Y of what? Y of 0. What is the Y of 0? You are assigning to I. How you are assigning the I? What about other outputs then? Same time. What about Y0, Y1, Y2, Y3? When select line is 0, 0, input is distributing to what? Y0. So Y1, Y2, Y3 should be floating state. Means what? Z. Operate the Z for that case. I can go with the concatenation. I can write 3 tick B Z Z Z. Or if I am going to write like this, Y is equal. Y is nothing but how many bits now? 4 bits. Now 3 tick B Z Z comma I. Then in this, what is the meaning of this? How this concatenation will work? I assigning to what? Y of your LSP. What is your Y of LSP is nothing but Y of 0. MSP is nothing but what? Y of 3. So in this case, Y of 1, Y of 2, Y of 3 will be what? I impedance, floating state. Did you understand? Now I is assigning to what? Y of 0. Are you clear? And what about next state is 2 tick B 0 1 colon Y is equal to what? Concatenation of what? 2 tick B Z Z comma I comma 1 tick B Z. Correct? Now I is distributing to what? Y of 1. When the select line is what? 0 1. Next is what? 2 tick B 1 0 colon Y is equal to what? Concatenation of what? 1 tick BZ comma I comma 2 tick B Z. Did you understand? Next, 2 tick B 1 1 Y is equal to 1. Concatenation of I comma 3 tick B Z Z Z. Correct? Then default. Now, can you write a different default case now? Means, if select line is XX, 0x or 1x, one condition is XX. Second is 0x. Next is x0. Next is z0. z1. Correct. Z is z. X is z. Select line I am talking about. Or zx. For all these state, what I want to do? For all these state, I need to write that invalid. Invalid. Okay. So you think of that how to write. Okay. Now simply I am going to write default. What I can write the default? Y is equal to 40 b of what? Xxx. Correct. When select line other than 0, 0, 0, 1, 1, 0, 1, 1, I should assign what? Y2, unknown. Is it clear? Then next is what I need to do. In the case, then always in the module. Now let us run this for our syntax errors. So there is no syntax errors to this. Can you quickly write the test bench to this? Let us copy the same test bench here. This one. What is the test bench to this? So input is what? I. Select line is yes. Then output is what? 3 down to 0. Then this is nothing but demultiplexer. What I mentioned, okay. Demultiplexer 4. Let us write 1 cross 4 demux. 1 cross 4 demux. Here also I am going to change this into what? 1 cross 4. Demultiplexer. Okay, then. So random generation of what? I and S. Then display. Then what I need to do? This is my formatted string ISY. This is my arguments I am passing to this. These are saying. Now let us run this program. You can see this output. This output. When select line is what? 0, 0. Input I is 1. 0, 0 means this will be distributed to what? Y naught. Y of 0. So remaining are what state? Floating state. Again 0, 1 means what? This is distributing to the y of 1. What is y of 1 is here? 0. This is y of 0, y of 1, y of 2 and y of 3. Correct. Now when it is 0, 1 is also still it is nothing but what? Y of 1. This will be distributing to the y of 1. Again 1, 1 means what? Y of 3. So y of 3 is distributing to what? 0. So remaining are a floating state, I impedance state. So 0, 1 is nothing but what? Y1. Correct. 0, 1 is nothing but Y1. So Y1 will be distributing to what? 1. I. I is 1. So 0, 1 is nothing but Y1. So I is distributing to the Y1. Now this is modeling as a what? 4 cross 1 multiplexer, demultiplexer. 1 cross 4 demultiplexer using case statements. Are you clear? Now can you model ring counter using case statement? 4-bit ring counter using case statement. What is a ring counter? What is a ring counter? How to configure the ring counter using flip-flops? What is a ring counter? Correct. Suppose 4-bit ring counter, 4 flip-flops. Let us take all these are D flip-flops. How data will be shifted towards the right using CISO. This is nothing but serial input and serial output. Output of this is feeding what? Input to this. So this is the clock. Correct. If I am writing this is QE, QB, QC, QB. Let us take the present states are QA, QB, QC, QD. If these are my present state, initially I am going to load like this 0, 0, 0. When I give the clock pulse, what is the next state is? What is next state is? QA, QB, QC, QD. What is next state is? 0, 1, 0, 0 state. If my present state is 0, 1, 0, 0, what is my next state is? 0, 0, 1, 0 state. If my present state is 0, 0, 1, 0, next state is what? 0, 0, 1 state. If my present state is 0, 0, 0, 1, what is my next state is? 1, 0, 0, 0 state. Where 1 is shifted initially. Did you understand? Now this you should model using case state. How to model this is nothing but a ring counter operation using flip-flops. How to model this using case statement, ring counter? How to model? How to model this using a case statement? When you think of this question, I want to model this ring counter using case statement. How to do this? Okay, let me give idea to solve this problem. So I want to model the 4-bit ring counter, correct? Behavioral model of 4-bit ring counter using case statement. So shall I start with the design file to this module? Shall I write module name is ring counter, ring? Let me write a ring counter. So what are the input to this clock? Shall I take the Q is the output? Did you understand? Then what are the input to this is nothing but clock. Output is output range of what? 3 down to 0. 4-bit ring counter I want to design. 3 down to 0. Then what I need to write? Always at the rate of, let us change this advantage. Positive edge of the clock begin what I need to do. Write the case. What is case to this is? Case of what? Is it case of clock? Or case of Q it is? So let us initialize this Q to port tick B1000. 1000. What is the value of Q now in decimal? In decimal it is 8. In binary 1000. Correct. So what is a case expression I should write? Case of Q. What is the alternative you can write? 4 tick. Okay, 4 tick D decimal number. So if it is, you can see what is my present states are. My present states are 8, correct. This my present state is 8. What is my next state is 4. If my present state is 4, next state is 2. If my present state is what? 2, next state is 1. If my present state is 1, what is my next state is 8. Correct. How to model this here? 4 tick. If my present state is 8, correct? What I want to do? Boolean Q is equal to what I need to do? Q is equal to 4 tick D 4. That's it. Correct. If my present state is what? 4 tick D 4. What I need to do? Q is equal to 4 tick D 2. Correct. My present state is what? 4 tick D 2 is equal to what? Q is equal to 4 tick D 1. Correct. My present state is what? 4 tick D 1 is equal to Q is equal to what? Is it colon? Alternative colon, correct. alternative colon. Then Q is equal to what? 4 tick D8. So very easily you can model the what? Ring counter. You can understand if you know how it is behaving, ring counter, that behavior you are modeling using what? Case statements here. Then what I need to do? Default. What I can do? I can assign 4 tick BR, it has assigned ZZ XXX other than Q value, correct? Then what I need to do? In the case, then in the always block, then in the model. Now let us run this for what? Syntax error. So line number 14. What is the mistake is, and I need to assign Q is equal to 4 tick B XXX. Correct? Now can you write the test bench to this? Module TB reg block, then while 3 down to 0 what? Q. Then I need to instantiate this ring counter DUT dot clock of what? Clock, comma, dot Q of Q. Then generate the clock, always at the positive edge of the clock, always #5, correct? Clock is equal to what? Not of clock, I am generating the clock generation. Is it clear? Next I need to do initial begin, initially clock to what? Clock to 0, correct? Then what I need to do? I am giving clock to 0. I am writing the positive edge of the clock. When you have positive edge of the clock, ring counter operation should happen. Initially I am doing Q to what? 1 0 0 0 means 8. The next rising edge comes 4. Next rising edge comes 2. Next rising 1. And again that should be repeating. Again 8 4 2 1. 8 4 2 1. So here I'm making the clock. Initially clock is equal to 0. Or what I can do, here only I can make clock to 1. Clock to 0 is also fine. Then here I am going to monitor this. Monitor of dollar symbol time, comma, what I need to monitor? Clock. Let me give the tab space. Clock is equal to %B. Then what I need to monitor? Q. Q is equal to %. Let me monitor in the decimal. Okay. Then what argument I need to pass? Clock, comma Q. Then let me finish this at 500. Dollar symbol finish. Then I'm going to end. Then in the module. Is it clear? Let us run this program. This is a test bench to ring counter I am writing. Now let us run this program. So it is ring counter is happening here. Let us copy the result here. So at the clock t is equal to 0, initially we are making Q to what? 8. Whenever the rising edge comes, what happens here? Ring counter. Ring counter means what? Next count is 4. Next is what? Next rising edge comes 2. Next rising edge comes what? 1. Next is what again? 8, 4, 2, 1. Correct? Again it is repeating 8, 4, 2, 1. Now this is working as ring counter. Did you understand how to model the ring counter? Using what statement? Case statements. So modeling of ring counter became very easy when you go with what? But case statements. You write the cases. Shift operator also you can do using what? Case statements. You think of how to model that using the case. Shift operator also you can do. Did you understand this? Suppose I want to do the sequence generator. So first count is 1, next count is 5, next count is 7, next count is 10. Any arbitrary sequence also I can model using what? Case statement. Did you understand this? So now let me give some assignment to you. You write a program to all this, okay, using case statements. So let us copy this. The assignment question says, so write a program. Now we have done JK flip-flop, SR flip-flop. Okay, write the behavioral model. Behavioral model of T and D flip-flop. D flip-flop using what statements? Case statement. Using case statements. Okay. The next one is, can you design the Johnson counter?
Class.
So Johnson counter is a multi-place clock generator. Correct. So write a program of behavioral model of 4-bit Johnson counter. 4-bit Johnson counter using case statement. Clear? And what other programs you can do using case statement? Can you write a program of sequence counter, arbitrary sequence counter? Let us write sequence counter using case statement. So let me give the sequence. The sequence is, you need to generate the counter like this sequence. Let us start 2, next 5, start with the 2, next count will be 5, next count will be, let us make 9, 8, next count will be 9, next count will be 12, next count will be 15, and next count it will be 2. What modulus counter it is? What modulus counter it is? First count is 5, next count is 2, first count is 2, next count is 5, 8, 9, 12, 15. It is a modulus 6 count. Correct. Arbitrary sequence I am giving. Did you understand? So try these programs using the case statements. And the next session we'll talking about case X. How case X and case Z will be help us to model some of the circuits. Okay, especially case X and case Z is using for modeling the parity encoder. So in the normal version of the encoder, we have a problem. Assigning will be not properly happening in the normal version of the encoder, so that we are going to assigning the parity. So parities are 2 types: assigning the parity to the MSB bits, assigning parity to the LSB bit in the encoder. So how to modeling the encoder, decoder using case X, cases statement. We'll see that later. After that, we'll go for the loops. Okay, for loop, while loop, forever loop, and repeated loop. You don't understand? So if you try these programs, yeah, hello.
Sir, if
Yes, hello.
I want to take a key value runtime, that time is logic is not working, right, sir?
Q is runtime.
I take key value as a runtime, sir. So that time logic is not working, right?
During runtime, you need to pass the value of Q. That is
Yeah.
not your question.
If
So
I
you can
take
use that will see initially I am giving this Q to 1. Say for example it is a 4-bit ring counter initializing to 1. Port tick B 1000.
yes,
So how to pass this as an argument from the loop? What you can use? How to pass? Before this case, what you can do? You can use this one dollar symbol one.
dollar
Dollar
symbol
symbol
value,
value.
yes,
Dollar symbol what?
plus,
Plus. Then args.
yes,
Correct. This is one system task function where user is providing the input to the program during the runtime. So before going to this case statement, what you can do? You pass the value, initial value to this. Correct. User defined value. You can
So,
model this one.
for example, if I want to pass the runtime means if you pass that value 8, you 4 decimal 8 value to convert to 4 decimal 4. But if I pass the Q value as a 10, 11, so that time that logic is not working.
No,
So
no,
without the
not work. Correct. Because that is not a modeling of ring counter, right? Our ring counter is nothing but. So first initial present state is 1000, and next state will be what? 0100. It is a
yes,
special code. Ring counter is a special code. What code it is? 8421 code it is. Correct. Non-binary 8421 code it is. If you are passing here as a 7,
okay,
if you pass this as a 7, it is not modeling as a 8421 code. Correct.
okay,
It will not model. It will not model as a 8421 code ring counter. If I'm initializing this with the 7 means initially it is taking this is a 7.
yes,
If this is 7, whenever this case matches only it will execute.
yes, sir.
Correct.
But that part we
Okay.
are
No
doing.
case. That part we are not doing in this case. Okay. If this is nothing but if it is not 7 means directly it goes here for the default. If Q is equal to 8, this statement will be executed. Q is equal to 4, this state will be executed. This case will be executed. 2 means this is executed. 1 means this is executed. If you are giving Q is equal to other than this 8421, what it is going to do? It will go to the default. Then it is making Q to what? Unknown, X. You got the point?
That is okay, sir. But you take the Q value as 8, right, initially. But I take the Q value as 9. So that time we are giving 4-bit decimal 9 we are giving, right, sir?
If I give 9, see, what is a ring counter, man? Ring counter, how ring counter is works? This is 000. Correct. Next state is
Yes,
nothing
sir.
but 1. This
0,
model I
1,
want to
0,
do.
0, 0, 0, sir.
1000, 0100, 0010, If I give 9, whether you can generate the 8421 code, if your initial state is 9, using ring counter, whether you can able to generate the what? Ring counter, it becomes what? 1100.
0, 0, yes.
0110. Again, this
0,
is what?
0,
0,
0,
0, 1.
1, 1.
Again, after this, again it is 001. Is the behavior of the ring counter it is? No, right?
Okay.
You should know that what model, what is the problem they're asking, what model you want to do, that you should know.
Okay,
Correct.
sir.
If
Okay,
I'm initializing 9, it is not modeling as a what? Ring counter. It is modeling
yep.
it what? According to the circuit, what you are writing. This is 9, this is 12, this is 6. Again, this is nothing but what? 3. It is some sort of pseudo random sequence generation. It is generating 9, 12, 6, 3. Again, 9, 12, 6, 3. Some sort of pseudo random sequence generator. It is not a sequence generator. Sequence generator means you can't be able to guess. After 4th cycle, again it is repeated, right? So this
Okay,
type
sir.
of counter we call it a pseudo random sequence generator. Now this we call it as a ring counter. 8421 code is nothing but a ring counter.
Okay, sir. Okay.
Okay, can you take up these problems? Okay, write the T flip-flop, D flip-flop, and also try with the registers. How you can model the register using what? Case statements. Try this. In the next session, we'll go with the case X and case Z, and then we'll go with the for loop statements. Okay. So now I request all of you to fill the attendance.